Hello, this is a workshop for distillation column and adjust command. And in the first case, we try to separate N-hexane from 2-methylpentane in the distillation column. And we would like to determine the number of tray and the optimum feed position. In this case, 50-50 weight fraction of these two chemicals are fed into the distillation column at 40 degrees Celsius, 1 atm, and about 507 kmol per hour. The specification is that purification of N-methylpentane will be about 97.5%, and for the hexane is 80% is okay, while the pressure loss in the column from bottom to top is around 10 kilopascal. So we start with the feed package. In this case, we are using SRK, and then we input the chemical of N-hexane. And 2-methylpentane. Okay. Now we can go to the separation. We start with temperature at 40 degrees Celsius, 100 kilopascal, and the flow rate of 507. With the composition based mass fraction, okay, things look okay now. And in this case, we would like to work on the separation at 300 kilopascal. Actually, I forgot to put that in the handout. So let's build up the pressure here. Oops. So we boost up increase the pressure by a pump. We increase to 300 kilopascal, and then before feeding that to the distillation column, the easy way is to put some heater here, so we can provide first the pressure, the condition which is ready for the distillation column. Okay, at this point, before we put into the distillation column, it's required to have the easiest way is to set that at the bubble point. So summation y equal to 1. So now they put some heat here and prepare for the feed before getting into the distillation column, and they are 2 distillation column that we work with, one with the shortcut, and then the information from the shortcut will be used in the legless one. So let's try to a simple way first. Here, and this till at D and B. My QC is required to remove the heat out, and this is for the reboiler. Okay. Now we have to understand which products, which chemical will go to the top and which chemical will go to the bottom. So let's go to check for the boiling point of each one. See, the boiling point of N-hexane is 68, while the boiling point of 2-methylpentane is 60. So 2-methylpentane will go to the top and hexane will go to the bottom, and we call 2-methylpentane is a light key. Light key is 2-methylpentane and hexane as a heavy key. And the heavy key will be contaminated in the distillate, which require for 2-methylpentane of 97.5. So the less would be hexane, which is about 2.5%. So 0.025, and we want hexane at least purification of 80%, so it's allowed to have that 0.2 of N-methylpentane in hexane products. The pressure drop from the bottom to the top is 10 kilopascal, so I put that 300 and 290 here. And now the minimum refractory ratio is 9.5. For the external refractory ratio is about 1.15 to 2 times of this. So let's round it with 10. So after I put the external refractory ratio there, the program is generate the result and giving that the maximum, the actual number of trays is about 70, and the feed composition is 50, while the temperature is about 98 and 106 in the bottom. So this will be used for the legless one. So what we're going to do is to work on the legless one by getting this information and using the legless one here. The molar flow rate. This is isomer from each other, so I can just put 0.5 and 0.5 to this. Okay, now we can connect that. Number 4. And let's make it total condensation. So it's just the reflux is just returned to the column then. And we have about 60 or 70 trays by feeding at 50. Let's put that QRR and QCC. Make that BB and GG. Okay. Now, the button up next is pop up, so we can click that. Click that. Just leave it that way. And pressure as 300 and 290 here. While the temperature is, I've got okay, 98 and 1/6. 98 and 1/6. That's the estimate values. So we don't care much, just try to put the initial gas to that. And now it's done. But the calculation cannot be made because some specification is required. For example, the purification. That's what we wish. So let's go to the specification. In this case, the default tells us about the distillation rate and reflux rate, and also the product in the bottom. Okay, how much we can get. So let's add that. We can leave it that way. So we work on the column component fraction here. Okay. And state number 1 with the mole fraction of Weber. And we want NHEP and pentane to be 0.975. Okay. Yeah, another one. For the one below. And that might be in liquid, which is hexane. You want about 0.8 at least. Okay, let's see. Let's see what we have here in the monitor. Okay, this is only the estimate. We can estimate that. So in this case, we fix the composition in the bottom to be 80%. However, we cannot make to 97% like what we want in the handout. But at least not too far from the specification. So let's see what we have here. We have the temperature profile. If we have the side stream, for example, for the refinery, we can just take the products in. You can make a decision on which state we can take the product off. Okay, that's all for the combination of distillation column. So first you do by the shortcut and then use information there to put into the regulars one, and then you have to make the product specification in this case. Okay, thank you for watching.